Hi everyone, welcome back. So today I'm going to show you how to download the real-time data of NWM, International Water Model. Sometimes we need to download the real-time data, right? So when you have any storm event or any flood event, so you need to download the real-time data set. So since I already have that type of event previously, the Harvey, so I'm going to download that data now because they already archived that data, right? So it is basically real-time data. So they have even reanalysis data product. So that is a different issue. So I'll show you that one as well in future tutorial, that how to download the archive data. That is called reanalysis data. So they use NL specification for their reanalysis from 1993 to 2017, and sometimes they have 2018 and up to 2019 as well in their second version. So NWM model has different versions, 1, 2, and now they came out only 2.1. So I'm going to download the data for the latest version, not the 2.1, but the 2 version that we have archived already for 2017 event, because the Harvey was in 2017 and they have the latest one, but I'm not gonna do that because I'm just exploring everything for the latest version. They have different archive, Amazon archive, so I'll also check that one, not a problem. So I'm gonna show you, I'll use a Python script. I've written a script in Python that can download that data one by one. If you specify your input and means your date range, the starting time and ending time, then it will start downloading everything for you. So let me quickly share my screen and show you that. So that is the HydroShare thread server or service. If you search for this one, I'll give you the link in the description below, and you'll have different types of options here. You can see NWM have right, it has 1.2 version archive for Hurricane Matthew, and basically these are for specific event-based archives. And you also have the general archives, 2.1 version and 1.2 version. Okay, so that's that. Here you'll see the real-time data set. These are the reanalysis, and they have many. Okay, analysis, assimilation. I'll describe in a separate video that what are the variable description, because NWM, it has 3 different types of output. For river, it has channel output, and for lake, it has lake output, and for land, it has also land surface output. So they have different outputs, but for this case, I'm gonna download only the data for the channel stream flow, right? Along with the stream flow, we will have even lateral flow and groundwater flow, different types of variable. We'll see after downloading few files. We'll open one netcdf file and see what are the variables there. So in order to download that, I have to copy this link. If you just click one by one, if I want to download analysis and assimilation, and I have this a lot of netcdf files here, right? If I click one, these are the channel output, ch channel and rt, and it is showing the times, and CONUS means it is the conterminous USA. It is covering entire USA, right? You can see that. And you also have assimilation and land. This is the land value, land surface, and you also have the reservoir, the lake or reservoirs. They have 3 different types of the same time step. They have 3 different types of prediction, or previously it was real time, but now it is archived. So if I click there, you'll have different options from HTTP server and from OpenDAP. If I click there, right, it will start downloading. But other than clicking there and browsing for the specific date and time, I'm not going to do that. This is time consuming, because if I want to download for 25 years and I have the data for hourly, so how many files I have? I have more than 100k file. So how can I download that? Right, it will take a lot of time. So instead of doing that, I'm just I wrote a script in Python to do the same job, right? So what I'm gonna do here, I'm just importing different URL, different module that can deal with or handle URLs. So these are the, I tested multiple times, and I'm using the request this time instead of wget. I'm using the request command. The request is another module that will help you to download data using URL. And if I want to read a netcdf file, you don't need that one for downloading, because I have the script that can download and read and create time series. So in separate video, I'll show you how to extract data from NWM using their specific ID of stream ID called com ID. So I'll show you how to download those, because you need some processing from GIS, and you have to download that one because they are using the stream ID from NHD plus 2 or NHD 2 version right now. So what I'm doing here, I'm specifying the start date. It is from August 22nd 2017 to September 11 because the Harvey hit at around August 29 to 30, and I'm creating a date time frame daily because these are the daily data. The real-time data are daily, but the reanalysis data that are hourly basis. And then I'm specifying the simple code I follow here, just downloading directory. Since the event is Harvey, I'm giving NWM Harvey, and if the directory is there, then it won't create anything. If it is not there, then it will create this folder or directory. And I'm specifying the base thread that I just showed you, and then I'm creating the list of the date, right? The way the file is arranged, it is based on the year, month, and day. So that's why I'm creating a list of date, specifying just from that start and ending date time. And because I'm creating a complete URL as before that I did for MRMS data. So they have one part analysis and assimilation, and they have this channel output, right? And I can show you again that they have this part right here. See, TM02, TM01, and TM02.conas.nc. So I'm just connecting. I'm creating the file name along with its URL as well. So that's it, nothing else. And then I'm looping through the date because I have to download one by one instead of clicking. So that's why I'm looping through the dates. I have the date list, and I'm looping through each of this date, and I'm creating the entire URL, and I'm using request to download that file for me, nothing else, right? So that is for 24 hour, a date and month. Time is 24 hour, and we have the month. So that's nothing else. I'm just using this script pretty simply. I tested it, and I'm just printing some message. When it's downloading, it will show the file is downloading, this is the name of the file, and it's downloaded. Once it's done, then it will show you that files. So that's it. It is pretty simple code. But you have to understand what is actually happening. The main logic is I'm just specifying the starting and ending date, and I'm specifying the output directory, and then I'm creating the URL. That's the important part, complete URL. Instead of clicking one by one, going back and forward, I'm just clicking automatically here, right, using that request command that is already built in. I'm just calling that function request, and I'm passing that URL, complete URL. It is doing the job for you. It is clicking basically, and it is downloading the data for you, and it is saving the directory that we specified. So that's it. That's why we use programming or coding that makes our job very easy, right? So for this type of code, you need to have Python installed, right? So let me show you, because I was trying here. So the file I have, the name of the code is this one, download_RT, because these are the real-time data, and I just displayed you that one. So for running this code, it's pretty simple. I'll describe that, because if you wanna download this data from previous version, the reanalysis, you don't need to even write this type of code in Python. I'll have a different code from shell script. You have to specify only your year and everything, then it will download the data for you, because they have different now server, Amazon server, so they just uploaded everything there. So it's pretty easy. They have some built-in function there. So if you just use specific command, you don't need to even write code in Python or in MATLAB anywhere. It will do the job for you. So that's different. So that's why it is a little bit different if you want to download the real-time data. Okay, so I'm running the code. Since it is Python, I'm calling the Python and the download and then real-time. If I hit enter, then see there is nothing like Harvey NWM. So it will create a directory called Harvey NWM. So I'm just showing you that. If I hit enter, see it started downloading, and if I refresh, see it create a new directory, NWM Harvey, okay, and it is just putting these files inside that. See, can you see that? Yeah, it's downloading one by one because the file is downloading for the entire USA, 2.7 million streams segment, right? They're just predicting or simulating for 2.7 million stream across this USA, right? That's why it's taking a little bit time, but still it's okay. See, it's already downloaded few files. If I just kill it, the process, and let me show you, right, what is actually happening. Or okay, I can show you from the different directory. If I open a new session, then I'm going to show you that what I have. I have these files there, okay. I have these files. Just let me make it bigger so that you can see. So these are the name of the files. It is increasing, okay. If I wanna see what is there inside, because these are the netcdf file, I can't open using any cat command or any text editor. That's why I need to activate my Python environment, or I have NCL, that is another command language. I'm just activating that environment so that I can easily open that file to see the variable descriptions and the name of the variable. Activate. So that is the variable I have. And now if I use the ncdump, okay, if I use ncdump, that is the command to read netcdf file. So I'm just reading part by part. Let's see if it works. Yeah, you can see the variable description for that. Well, I just opened one file, so the data are different, but see what do you have? The feature ID. So these are the number of feature ID we have. It is 2.7 million, right? 2.71 million. These are the total number of stream segment. So we have data for each of this. This is the time series data. And then I have the time. The time is the valid output time, and it is starting from this. So the time it is there, it is starting from this one. If you are familiar with netcdf format, I have one video that shows how to read netcdf file. So you have to have one reference date. So it is a minute from this one. You will have a number, and you have to calculate how many minutes from this date, 1970 and 1st of January and 00 UTC. And field value is this, and it is basically the river description. And what is the unit? It is stream flow, meter cube per second, right? And you have the coordinate, latitude and longitude for each of this stream segment, okay. And then you have the feature ID as before, and you have another, because this is the nudging, they are using the observation data, forcefully using that one. That's why it's called real time. They use this nudging technique. And you have the lateral flow as well, Q lateral. If I just go more, you also have, see, Q, you have the stream time, stream flow, and you have the nudging, you have that Q lateral, you have the velocity for each of this stream ID or segment, you also have that ID, okay. So in the future video, we'll see how to extract the stream flow as a time series for any specific stream segment using their common ID. We'll do that, okay. I have written a script to do the job. I'll show it gradually, not a problem. And then you can see the time. So this means I have this time, the number is big. These are in minute from 1970 and from 1st of January. So you have to convert this number to your date, and if you convert it to your date, so it is nothing but the date I specified, the beginning date, okay. The date I specified here, that would be the 1st August 22, and starting from the 00, it will be that date, or it is showing the minute. If you calculate using your calculator, definitely it will be that date. And it is showing the stream flow value. See the values of stream flow. These are, you can see that, and I even can't finish. If I just hit my space bar, it's showing the values. So that's why I just opened, right? Even it is not showing any 0.1 percentage. What about the downloading? See, it's still downloading. So for downloading this data, you have to use either you can run this code. Since it is the Python code, you can use your Windows machine as well. You can use Jupyter Notebook, or you can use Spider. You'll be able to download that data, not a problem. But If you want to download the archive version, then you won't be able to download using your Windows. So you need to use your Windows command, or you have to use a Linux machine, because that needs a space, because the scripts are already there. You have to call the executables, the binary, because in order to call that executable, you need to have their command, and then you have to install that previously. Okay, so I have everything installed, so I'll show you only how to download those data, but you don't need to write all these lines that I wrote here for Python. You don't need that. You need only few lines, and you are just basically asking, okay, do this job. I'm giving you the year, so the thing I'm doing here, I'm specifying the starting time and the ending time, and it is doing the job for you, right? So that's that. We'll do that. We'll specify only the date or the year, and it will download the data for you, because the executables are already there. It will call the script, the shell script or the C script, and then it will download the data for you, because that is a little bit different. They have different archive for the reanalysis data, but since these are the real-time data, so we have different archive and different command for that one. Okay, so that's that. So it is pretty simple. Once you have your data, and if you know the variable description, and it is another step to extract this data for your study area and for your stream segment. If you want to validate this NWM, that's the most important part people are doing right now. So now we have USGS observation, or you have any other observation data, you need the stream flow for the same location, right? So how can you do that? Because they have different segment. So you can click, okay, using your GIS, I'll show you, but before that we have to open that shape file for 2.7 million stream, and you have to extract that ID. Once you are once you have the ID of that stream, then you can use that ID to extract data from this netcdf file. Since these data are in hourly or whatever it is, maybe it is in daily, not a problem, then you'll extract data from each of these files and you can make the time series. So I'll show you how to do that. Even it is not a problem, I'll show you. So that is the logic, because for extracting this data you need to create something like this, because I prepared everything there. Here you can see you have to have this type of input files, right? The CSV files, you have to pass one CSV file as table, and then you have to even specify your stream ID. Here, see, I'm giving this number of stream ID, I'm downloading this much data. How many stream segment I have? It is more than, see, it is like 962, and these are the stream ID. So I'll ask the code, okay, give me the time series for this ID. So it will look for this ID out of this 2.7 million, more than 2.7 million IDs, and it will find out the data for me, and it will make a time series. So there will be 917 time series. It will create separate 962 CSV file for each of them, and I think I already have that, right? The real-time data, and these are the CSV file. See, at first it will create the CSV file as time, and out of this CSV files I'll make my time series. Okay, let me show you if it is there. So time series, okay, so here, see, it is creating the time series, not now, but I created this one previously, so I'll show you how to do that. I have the script ready, and it is creating that time series, and it is CMS, means stream flow. I'm just gonna plot you quickly here. You can see using Excel, even though I don't use Excel to plot, I'm just showing what it will generate. See, it will generate that type of stream flow because it is for Harvey, and I have used flow for Harvey, right? So it is 6,000 CMS, meter cube per second. It's pretty big amount. So we have to generate this one, and you will know the location, and then if you have the observation, then you can validate or calibrate your model. If you don't have any observation, then you can use NWM as a standard, right? Because even though NWM, they're trying to calibrate it, the model is not fully calibrated yet, so they are trying to calibrate the model. So sometimes the performance of the NWM it's not accurate. That's why we are doing research on that how can we improve the performance of NWM and what is the present performance of the NWM model. So people are trying to validate this model, and you'll see different types of papers, right, coming out. So I did the same thing, so you can even download this way. So that's it. I'm gonna finish off here, and you can try by yourself, and if you have any problem you can let me know, or you can even figure it out by yourself. And there are a lot of information, but for downloading NWM data you won't be able to see a lot of information. That's why I'm trying to create something that may help you, and you can continue your research as well. So that's that. So thank you very much for watching, and I'm gonna finish here, and stay safe. See you in the next tutorial.